Welcome to session 5 of Learning Scratch 3.0 with Fun. In the last part, we had done a couple of programs and we had some assignments also. So if we see the last two, figure A and figure B, before we do them, we need to understand about the coordinates. So let's begin with that. So we type scratch.mit.edu on the web browser and there we are. Let's create. But there seems to be some trouble. You're not able to see the file. So it's better we switch back to our offline version of the Scratch and it's going to produce the same results that is known to us. So let me turn off my video. Here we have an interesting mathematical concept called coordinate geometry. And it's just like having vertical and horizontal number lines placed together. So we have been doing it in the form of X and Y values, which used to be taken by us for bringing the cat sprite to the center of the stage. So let's understand it from the Scratch perspective. So we do one thing, we take a backdrop and we choose a grid. Since we don't require this cat sprite right now, we delete it and we maximize the stage. So now if you see, you'll be able to connect better. So we have the first portion over here, which is called the center, and this center has the coordinates which are x0 and y0. This is called O. And on the right side, we have x-axis. On the upper side, if we start moving from origin to y, we have the y-axis. But if we move towards the left side of O, we get negative values for x. So this is negative x-axis. And if we move downwards, we actually get the same y, but that is negative. So you can see the coordinates. We have x and y as 0 and 0 for center, x as 240 and y as 0 for x as 0 and y as 180, x as 0 and y as minus 180, and x as minus 240 and y as 0. So wherever you go, you need to be specific about the coordinate on which the sprite is available. So with this brief understanding, we can actually have the size of the screen also coming into picture. So if we see, this is 240 from 0 to negative x-axis and 240 from 0 to positive axis. So in actual, the total length of the x-axis is 480 units. Whereas if we do the same exercise for our y-axis, we will be getting 180 plus 180, which is 360. So the size of our screen is 480 by 360, which is 1,72,800 pixels is the size of our screen or the resolution of our stage window. Isn't that interesting? So with this little knowledge in mind, we go back to our main objective. The objective for us is to create the two shapes. So we'll start with figure A first, and then we'll go to the figure B. And the coordinate geometry idea which we have right now is something which we are going to implement. Since we don't have any sprite as of now, you will see that most of our options are unavailable. If I click on pen, you can see only erase all. If I click on motion, you don't see any of the blocks over here. So that's because there is no sprite over here. So what we do is we paint a sprite this time. So suppose I want a square sprite to be there. And what I do is I lock its center with the lock which is there on the drawing board. So this is quite huge. I can select and reduce its size and again place it in a way that it actually is at the center of this locking position. So there we are. We go back to our code, and since we have our sprite in place, you can see the motion blocks have come into action and even the pen options are actually highlighted. So we go to event, we take our flag We go to pen, we erase all in case there is any previously done drawing which can be erased with this. Now, very important, we go to pen up because we want to utilize the center of this stage. So we go to motion and we ask it to go to 0, 0. That is the origin, which is the center. And then always point in direction, which is 90. Now we can ask it to do a pen down. And once we are done with this, now comes the movement part in action. So the first part is to move a bit forward. So we say move 30 steps. And then we want to take a left turn. And that left turn is 90-degree turn because it has to make a staircase. So stair goes up and stair goes down. That was the shape which we have to do. Now again we move say 30 steps. And then now this time we won't be moving anti-clockwise, we will be moving clockwise. So we take it as 90. Again we move 30 steps. You'll say that we could have used some of the other repetition over here, but the challenge is after 3 steps we have to change the way the program behaves. And again we use 90 over here. So this is the first part of the program. Now we have moved from something like this. So we started from here, we moved, we took a turn, we moved, took a turn, we again moved, we took a turn. So we have to again move. So now what we do is we move 30 steps and then we take a right turn. So we take a right turn, which is again 90. And again we move forward. And then the situation comes wherein we have to actually take a clockwise? No. Anti-clockwise turn, which is again of 90. Again move 30. And then again move 90. Then again move 30. With this, we have our program in place. But these set of steps are kind of repetitive. And for eliminating them, we can have something from the My Blocks. So we go to My Blocks, we pick Make a Block. Now, mostly if we see, we are actually turning left and then we are making the sprite move. So let's name it as left plus move. And we can have one more, which is right plus move. So these two will solve our challenge. Let me remove this annotation. And if we have left plus move and right plus move in place, the program should have either of these steps. So this is left plus move and this is right plus move. So these two blocks are going to act as function to the main program. The main program will call them, they'll execute their set of steps and move or give command back to the main program. So right now, if we see this part, we have to eliminate this. So we actually go and give it back to the palette. Initially, we will require movement of 30 steps and thereafter only the left plus move and right plus move can be functional. So what we do is, right after moving 30 steps, we have left plus move. So hope you can connect it better now. This is the one with, these are the two blocks which is being replaced by left plus move. And the next one is right plus move, again, left plus move, again, right plus move. Now be careful, again right plus move, then left plus move, then right plus move, and then left plus move. See, our program length has gone decreased. So basically, we don't require this portion now. And our sprite should be good enough to work with only these three. So to show the effect, and it's going to act in the same way, let's erase all and we hit the flag. Great, it worked in the same way. So we learned something new, and that is to use My Blocks to have those portions of the program into it, which are actually kind of repetition, or we can also call they are a kind of a function which the program calls and then they return the value to the main program. So isn't it amazing? So this was one of the assignment questions and we are done with it now. Our next aim is to make a symbol which was something like this. So if I quickly draw it, it's going to be something like this. Hopefully it's correct. Yes. So for making this program, let's go to the events. Let's go to the pen. We erase all. We do a pen up. We go to the center of the stage. And then we do the pen down. So once the pen down is done, now our main thing starts. So if we choose the move steps as 50, then what we do is we take a turn. So this turn is going to be a 90-degree turn. Again, this time I won't ask it to move 50, but I'll ask it to move 100 steps. Then take a right turn, and that turn is going to be again of 90. Again, move 50 steps. Now this creates the first part. So to relocate the sprite, I do a pen up and then I ask it to take a 90-degree turn and we ask it to move say 100 and then that's all. Now we do the pen down. So this will help us to trace the path back. Now path back, that means we have to have minus 50 and then again we take a turn which is going to be anti-clockwise and with the 90-degree. Now movement on this side will again be of minus 100. So hope all the things which we have learned till now are coming alive over here. And no, not this one. We take 15 degrees and convert it into 90, which is clockwise. And then we do the last step, which is move minus 50. So that's all. Let's see how our sprite does this. First of all, let's bring this sprite back to normalcy. So this is going to be, we can even fix this from here. So we'll go point in direction always 90. Correct. There we are. Let's hit the flag. Wow. And that was pretty good and quick. So hope you'll be able to draw it now. So there is no repetition which is actually happening over here. So we won't use my blocks, but this is the quickest way to make the swastik symbol. So let's do it again. Yeah, that's pretty good. Let's advance slightly further. But before we go ahead, we'll do one quick thing. So suppose we have this as a square, and then we have another square inside it. Okay. So basically, this must be the center for both the squares. So whenever we have two figures or more than two figures sharing a common center, they are said to be concentric. And in this case, it is we have concentric squares. We can have similar thing, which is going to be concentric triangles or concentric circles is also possible. So two different figures sharing a common center are said to be concentric. Now let's make this aim of our program. So what we are going to do is for these two figures, we are going to have the cat sprite run and do it for us and then place them in such a way that both of them share a common center. So let me clear these annotations and let's begin. Here we have our cat sprite who's going to do this job for us. So we go to when clicked and definitely I'll ask it for a pen up and then erase all and then we go to motion and we ask it to start from the center. So that's actually going to give us a very good grip. Now for making a square, we know that we have to use repeat 4 times and that's not something which is unknown to us. We go to pen down within this and it's simple for us. We move say 100 and then we take either of them. So suppose we take this as a 90-degree turn and we put a weight also over here. So that's it. And then we ask it for a pen up because otherwise we're going to mess up the diagram. So let's hit the flag, and there we have our square ready. Now this is one of the square. Now in order to make a square which is inside it, so the total length is 100. So what are we going to do is we're going to take 1/4 of the size. That is going to be 25. So we go to motion and we go to x25 and y25 because we are doing it in the first quadrant. So both of the values should be positive. And then again we can duplicate this, but this time we are going to move half the steps that we had moved earlier. And that's all. Our program is fit to go. And suppose we do an erase all, and then we see it from the very beginning. So 1, 2, 3, and go. This is the first square, and here we have the second one. Great. Now, if you want to identify the center, so in case we have this particular portion over here, hope it is visible because I chose a yellow color. So we have to find the coordinates for the center. So you'll be able to find it out from the grid. So for that, we remove all the drawings, and then we go to the backdrop and we ask for the grid, and let this grid decide where are we right now. So we have this as 100, we have this as 100. So these are the values of x and this is the value of y. Now if we have to find this particular value over here, so this is going to be 50, isn't it? 50 for x and 50 for y. So great. With this, we make the concentric squares. Was it easy? Let's change our aim and make colorful circles. So we are already acquainted with one program which we had done related to the patterns. So we go to events, we select erase all, and then we do a pen up. We make it move to the center. So we go to x0 and y0, and then we do a pen down. So it actually avoids all the scribbling which happens unnecessarily on the screen. And then we ask it to have set pen color to, and then we go to control, we take repeat, and we ask the repeat to happen 100 times. Now we know for creation of a circle we require 72 into 5. That is the standard what we have used till now. So let's use the same. There are different ways also, but let's stick to it for a while. And we are going to move say 5 steps and take a turn of say 72 into 5. So that makes it 360. So this is the block for creation of a circle. Now along with this, what we are going to do is once a circle is created, we want the another circle to be having a different color. So we go to pen again and we go to change pen color by say 10. But this should be placed after the circle gets completed. And then one more thing which we are going to add to it is a clockwise, say 10-degree turn. Ready to go? Let's save this project of ours as colorful circles. Ready to hit the flag, and there we are. So the first one, the second one, third one, and all of them are actually having a change in color. So it's the same program which we did in one of the sessions, but this one is with change in the color of each circle. So that is what makes the difference while we did this program. It's a bit slow in terms of execution. Let me put it onto a full screen mode so that we see all the vibrant colors. And this completes it. So let's go back and we stop our program. Hope you liked it and do save it to your computer as well. Since we have reached middle of the program, let's have a quick recap of the terms and the coding discussed till now. We learned computers understand only zeros and ones. Computers require inputs and instructions to give a desired output. Scratch is a block-based programming language which makes us focus on the logical part of the instructions. We need not be concerned about the syntax. Also, algorithms are a step-by-step way of solving a problem. We discussed stepwise and logical thinking. Some problems have to be solved using only fixed steps, whereas others can be solved randomly to obtain the desired output. At times, we have to use logic, compare big or small, red and green, etc. to come up with a solution. We also learned about the basic layout of the Scratch interface. We learned about the different sprites, movements, turns, pen up, pen down, making a line, making basic shapes like square, triangle, circle, etc. We used repeat block, costumes, animation, sound, backdrops, angles, coordinates, forever block, if and if else. We created my block, made patterns, even the random pattern, changed the size of the sprite, made a square inside another square, made the sprite fly, and changed sprite costumes. Hope you are having fun learning Scratch. With this, we come to an end of session 5. We will meet again in the next session. Till then, happy learning!